In this video, we will explain linear equations of order 1. Just to get an idea of that, if we have two variables, let's suppose x and y, a linear equation is something that looks like ax plus 3y, let's say, 2x plus 3y equal 4. Then the variables x and y are raised to the power of 1. They are not supposed to be multiplied with each other, and the coefficients are supposed to be numbers. When we think about a differential equation of order 1, to decide if it is linear, the variables are going to be y and dy dt. And the coefficients, instead of being numbers, they could be functions in terms of t. Then we can have like something like 3t squared y plus 2 sine of t dy dt equal to cosine of t. You see here the variables are y and dy dt. They are not multiplied with each other, and they are not like raised to the power of 2 or 3 or something like that. And what is making the role of coefficients are functions in terms of t, or it could be just numbers. And then when you have something like this, we say that this is a linear function. In general, we can write a linear function in this form. We can just solve for dy dt, and we can say dy dt plus g of t times y equal b of t. Then you can say a function is linear if you can rearrange it so that it looks like that. Let me see some examples. If you have something like 2t squared plus 7 dy dt plus 2 times y equal to sine of t. Then I can make it look like that by dividing by 2t squared plus 7. Then I will get like dy dt plus 2 over 2t squared plus 7 times y equal sine of t over 2t squared plus 7. Then when it's written like that, we can say that in this case, this part here is the g of t, and this part here is the b of t. And anytime we can rearrange and make it look like this, then we can say this linear, and then we can just find out what the little g of t is and the b of t is. If you have something like y dy dt equal to sine of t, is this linear? Then we say no, it's not linear, because the two variables, the one that matters, y and dy dt, they are multiplied with each other. Then this is not linear. Or if you have like dy dt plus sine of y equal to sine of t, is this linear? Let's see, the variable dy dt is just raised to the power of 1, but here sine of y, the variable y, which is an important variable, is not to the power of 1. There is a sine of y there. Then this is not linear either. Then we're going to write down the theorem that is like the most important theorem regarding the general solution of a linear system. Then let me write that theorem. Maybe before doing the theorem, let me explain what a homogeneous and non-homogeneous differential equation is. Let's say definition. Then we know that if we have something of this form, this is called a linear equation, right? This is linear. But then if b of t is different from 0, then we say that this differential equation is the linear equation is non-homogeneous. Non-homogeneous. And what happened if b of t is 0, then the linear equation is homogeneous. And more important, let's say that this is the differential equation start. Let's say, and if b of t is different from 0, then this differential equation, the y dt plus g of t times y equals 0, this is called, and this is going to be important, this is called the homogeneous equation associated with this non-homogeneous equation. Then this is going to play an important part. Let me do some examples. Then if I have like dy dt plus 2y equals 3 sine of t. This is linear. And is it homogeneous or not? We see that the b of t is different from 0, then this is non-homogeneous, right? This is non-homogeneous. By the way, this part here is called, this part here, when it's non-homogeneous, this is called the non-homogeneous part. And then the terminology says that if you have a non-homogeneous equation, then if you kind of replace the non-homogeneous part with 0, what do I get? I get dy dt plus 2y equals 0. How is this differential equation called in relation with this one? This is called the homogeneous equation associated with this non-homogeneous equation. Then if we have a non-homogeneous equation and I ask you what is the homogeneous equation associated with this one, you just identify the b of t, identify the non-homogeneous part and make it 0. Then these two equations are different, but this is called the homogeneous equation associated with this non-homogeneous equation. Then let's see what the theorem says. Let me erase all of this. It says that if y of p of t is a solution of the non-homogeneous equation dy dt plus g of t times y equal b of t. Notice that I'm requesting to have only one non-homogeneous or only one solution of the non-homogeneous. Notice that in general, if I have a differential equation, we have infinitely many solutions, but I'm just asking you find at least one. If you can find only one equation and let's say y h of tc is the general solution of the homogeneous equation dy dt plus g of t times y equals 0. Notice that for the homogeneous, I'm requesting to find the whole general solution. It has a constant c. Then the general solution of dy dt plus g of t times y equal b of t, the general solution of this one is y equal to y sub h plus y sub p. Okay, this is the theorem. let's see, let's do an example that has to do with this theorem. Let's suppose that we have this differential equation, dy dt equal to y minus 6. Then let's see if we can find an equilibrium solution of this. How do I find an equilibrium solution? We look for something of the form y equal a. If we make y equal a, the derivative is 0. And then we have 0 equal to a minus 6. Can we find a value of a that makes this true? And we know that a equal 3 is a solution. That means that in this example, y sub p equal 3, the constant function 3, is a solution of this non-homogeneous linear equation. Why is it non-homogeneous? Because this is the non-homogeneous part, in this case it's negative 6, and it's different from 0. Then the theorem says if we can find a solution, just one solution, this is one solution of the non-homogeneous equation, and we can find the general solution of the homogeneous. Which one is the homogeneous equation associated with this one? What do I have to do to find the homogeneous equation associated with a non-homogeneous one? We have to make the non-homogeneous part equal to 0. Then let's see here how to find y sub h. We have to think about this differential equation. You see, they are different. What's the difference? That I did the non-homogeneous part equal 0. Do we know the general solution of this? This is, we have seen this before. In general, if we have dy dt equal k times y, what is the general solution of this? Y equals c e to the kt. And in this case, we have the general solution is c times e to the 2t. This is the general solution of the homogeneous. Then this is the homogeneous, this is the general solution. And then what the theorem says is that the general solution of this differential equation is the general solution of the homogeneous, which is c e to the 2t plus the solution of the particular. Then this is the solution of that differential equation. Let's just, for fun, let's check that indeed this is a solution of that, right? What happens if I do the derivative? If I do the derivative, I get 2c e to the 2t. And the question is this equal to 2 times the solution, c e to the 2t plus 3 minus 6? We can check that we have that indeed this is true. Then, if you want to solve a non-homogeneous linear equation, you need to just somehow find a solution of the original equation and then find the general solution of the homogeneous. Usually the homogeneous is easier than the non-homogeneous, and then you can find the general solution. Let me do another example. Let's think about example. Dy dt equal 3y plus 4 e to the 2t. And what we're going to do, the difficult part is to find the solution, a particular solution of this. What is the homogeneous equation associated with this non-homogeneous equation? Which one is the non-homogeneous part? The non-homogeneous part is this one. Then the homogeneous equation associated with this non-homogeneous equation is dy dt equal 3y. And what is the solution of this homogeneous equation? It is, according to this, is c e to the 3t. Then we have solved the solution of the homogeneous. Now, how can we find a particular solution? Usually what we do is we look at the non-homogeneous part and we try to look for something similar to it. In this case, we look for something of the form a e to the 2t. And let's see what happened. And we look at it is an exponential function with of the form e to the 2t, just a number, then we look at in general, something like this. If I want this to be a solution of this differential equation, when I take the derivative, I get 2a e to the 2t equal 3 times the function a e to the 2t plus 4 e to the 2t. And then how can I solve for a? Here I have that negative a e to the 2t must be equal to 4 e to the 2t. And I find an a that makes this true. And I say, okay, if I make a equal negative 4, then this is a solution. Then this is a solution of the original equation. This is the solution of the homogeneous. Then I can say that the general solution is y equal to the particular solution, which is negative 4 e to the 2t plus the solution of the homogeneous, which is c e to the 3t. This is one way to do it. Let me change the problem a little bit. Let's suppose I have dy dt equal 3y plus 4 e to the 3t. Then in this case, the solution of the homogeneous is just this one, dy dt equal 3y. That means that the solution of the homogeneous, I already did it, is c e to the 3t. And then let's see what happens if I look for the particular solution in this way. If I try to look something like a e to the 3t, if I try to look for something by seeing at the non-homogeneous part and trying to look for something similar. Let's see what happens when I replace here. Let's see what is the derivative of this function. It is 3a e to the 3t equal to 3 times a e to the 3t, right? 3 times y plus 4 times e to the 3t. Can we find the a? And here you see that the a cancel out, and I will get like 0 equal 4 e to the 3t. That means that there is not such an a that makes this work. That means that in this case it didn't work. Why it didn't work? We will see that the reason this is called the first guess. The first guess didn't work is because when you look at the first guess and you look at the homogeneous, the solution of the homogeneous, they are essentially the same. Then anytime that happens, then my suggestion is when you have a non-homogeneous differential equation of order 1, first find the solution of the homogeneous. Then you look at the non-homogeneous part and you make a first guess. But then before you try to see if it works, you have to decide if that first guess is essentially the same, is a multiple of the homogeneous. And if it is a multiple of the homogeneous, you need a second guess. What would be the second guess? The second guess is just the first guess multiplied by t. Let's see if this works. Then we want to take this one, didn't work. And then let's see if this works. Then I take the derivative. What is the derivative here? I have to use the derivative of a product. A times e to the 3t plus 3at e to the 3t. This is the derivative of the function. The equal 3 times the function at e to the 3t plus 4 e to the 3t. Let's see. We have that these two parts cancel out. And then we have that a e to the 3t must be equal to 4 e to the 3t, and then a equal 4. That means that the general solution of this differential equation is going to be y equal to the solution of the homogeneous, c e to the 3t, and then plus the particular solution, which is 4 times t e to the 3t. This is the solution of this, the general solution of this non-homogeneous linear equation. In the next video, we're going to explain how to solve a differential equation that looks like this: dy dt plus, let's say here is a number, a times y, and here, this non-homogeneous part, let's call it f of t. This is going to look like either a polynomial or like a exponential function, or like a sine of kt or cosine of kt, or a combination of all of this. Then we're going to be using a guessing technique and this theorem that we have shown that in general, the general solution of a differential equation like this is going to be the solution of the homogeneous plus the particular solution. We're going to go deeper into this. Okay, let's stop here.